Question 7 says, find the tension in each chord in figure 5.7 if the weight of the suspended object is W. And 5.7 looks like this. So there is an object suspended from a cord that is perpendicular, hanging from another cord like this and another cord like this. Here is an angle of 45 degrees, and this is an angle of 30 degrees. The weight of the object is weight W. This is chord C, chord B, and chord A. So the first thing I'm going to want to do is to set up Newton's second law, and I'll do that in the y direction. So I'm going to, well actually first I'm going to draw a free body diagram first of this system right here. So this is my object with a force downward of W and force upward of tension C. And so the sum of forces in the y direction equals tension C minus W. And the object is not accelerating, so that equals 0. So tension C will equal 0 if we solve for W, if we solve for tension. So I'm going to write that down. That is the first answer, is tension C equals W. And I can erase this. My next system looks like this. This is the intersection point between the three chords. We have chord C pulling straight down with tension C. We have tension B and tension A. And the sum of forces in the y direction equals tension A in the y direction plus tension B in the y direction minus tension C. And it's not accelerating, so the forces sum up to 0. And I can solve that as TA in the y direction plus TB in the y direction equals TC. Now to find the tension of A in the y direction and the tension of B in the y direction, I can use a bit of trigonometry, where I take the tension A times the sine of this angle here. I'm going to call that theta A. I do that the same for tension B. So plus tension B sine of this angle, theta B, or 45 degrees, with theta A being 30 degrees. I'm going to turn my board here and rewrite that here. Tension A sine of theta A plus tension B sine of theta B, and that equals tension C. With tension C equaling W. So now I need to do Newton's second law for the x direction. So the sum of forces in the x direction equals, I'm going to draw my free body diagram again, of this direction, and this direction, tension C, tension B, and tension A. So in the x direction, I just have tension B in the x direction minus tension A in the x direction and that equals 0. So tension B, I'm going to use trigonometry here again, cosine of theta B equals tension A cosine theta A. Now I have two equations that I can use to solve for these two unknowns, tension A and tension B. So I'm going to solve for this here, tension B, in this equation. So tension B equals tension A cosine theta A over cosine theta B. And I'm going to write this down for later. Tension B equals tension A cosine theta A over cosine of theta B. Going to move this equation here. Now that I have tension B solved for, I can put that in here. So that this equation no longer has tension B but only tension A. And so that gives me tension A sine of theta A plus, and I take what I found for tension B, which is tension A cosine theta A over cosine of theta B, and then multiplied by sine of theta B equals W. So now I'm going to solve for my tension A. I can do this by by factoring tension A out. So I'm going to do that now. Tension A times sine of theta A plus cosine theta A over cosine theta B. Sine of theta B. And so tension A, I can solve for that now, equals W over all of this right here. So that is the sine of theta A plus cosine of theta A sine of theta B over cosine of theta B. Now I'm going to insert theta, which gives me that. Give me a moment. Tension A equals W over sine of A. Sine of theta A was 30 degrees. Theta B was 45 degrees. So sine of 30 degrees is 1/2 and then plus the cosine of 30 degrees, which is the square root of 3 over 2 times the sine of 45, which is the square root of 2 over 2, over the cosine of 45, which is also the square root of 2 over 2. There's a square root of 2 over 2 on the top and on the bottom, so these cancel out, leaving me with W over 1/2 plus square root of 3 over 2. I can multiply the top and the bottom to cancel out these 2's, giving me that tension A equals 2W over 1 plus the square root of 3. So tension A equals 2W over 1 plus the square root of 3, which, if you put that in a calculator, gives me 0.732 W. Then I can plug this in for my tension B. Tension B equals tension A cosine of theta A over cosine of theta B. So take my tension A, cosine of 30 degrees is square root of 3 over 2. And cosine of 45 degrees is the square root of 2 over 2. Put that in a calculator, plugging in for tension A, and that gives me that tension B equals 0.897 W. And so that's my answer. Tension C is W, tension B is 0.897 W, and tension A is 0.732 W. And 7, part 2. The figure shows an object suspended from 3 cords. First one perpendicular, the next one going into this wall, and the next one going into this wall. Between here is 60 degrees. Between here is 45 degrees. And the object has weight W. This is chord A, chord B, and chord C. And I need to find the tension in all 3 chords. So I'm going to start by looking at this system. I'm going to draw a free body diagram. So this is my object. It has a force of gravity equal to W, and then a force of tension, tension C. Now if I look at the sum of forces in the y direction for the system, that equals force of tension C, tension C, minus W. And since the system is not accelerating, they sum up to 0. So I can say that tension C equals W. So I'll write that down. Tension C equals W. And that is my first answer. Now I'll go on to the second system, which is this point of intersection right here. So that's the point of intersection. I have tension C, tension B, and tension A. Now I need to break up these different vectors, these different tension vectors, into an x direction and a y direction. So going in this direction, x positive, is the tension of B in the x direction. Sorry, this is wrong. This needs to go this way. Tension A. Tension B in the x direction is what goes here. Then up here is tension B in the y direction. This is tension A in the x direction. This is tension C plus tension A in the y direction. And now I will set up Newton's second law for this system, starting in the x direction. So the sum of forces in the x direction equals tension of B in the x direction minus tension A in the x direction. And since the system is not accelerating in the x direction, this is 0. So I'm going to try to write around that. If I want to find tension B in the x direction, I can use a bit of trigonometry. Tension B in the x direction equals tension B. I'm looking for this direction here. I know 45 degrees, my theta B, and this is my adjacent side of the triangle. So I will be using cosine. So tension B cosine of my theta B minus my tension A, and so I need to find this here, which is the opposite side of my triangle, so I'm going to use sine of theta, sine of theta A. So tension B cosine theta B minus tension A sine theta A equals 0. And I'm going to do the same thing that I did with the first problem. I'm going to solve for one of these variables. I'm going to solve for tension B. Tension B equals tension A sine of theta over, this is theta A by the way, over cosine of theta B. So I'm going to write this down, that tension B equals tension A sine of theta A over cosine of theta B. Now I'm going to look at the system in the y direction. So the sum of forces in the y direction equals my tension of B in the y direction minus tension of A in the y direction minus tension C. So tension B in the y direction equals tension B. Last time I used cosine of B, so this time I'm going to use sine, or sine of theta B. And then tension A in the y direction equals tension A cosine of theta in the A, cosine A. Oh, and by the way, since the system is not accelerating in the y direction, this sums up to 0. And back down here, I could actually say that this equals tension C if I add this over here. Now what I'm going to do, since I have tension B solved for, I'm going to insert it right here. And that gives me, what I had for tension B was tension A, sine of theta A, over cosine of theta B. So I'm going to write that tension A, sine of theta A, over cosine of theta B. And I put in the rest of the equation, times sine of theta B, and this goes there, equals this. Now both of these terms have TA in them now, so I can solve, or I can factor those out. So tension A times sine of theta A over cosine theta B times sine of theta B. This is part of the same fraction. Minus cosine of theta A all of that equals tension C. So tension A equals tension C, which, by the way, tension C is found earlier, is W over, and as I put this under here, I'm going to plug in the angles. So the sine of 60 is square root of 3 over 2 times the sine of B, 45. Sine of B equals, the sine of 45 equals the square root of 2 over 2. Over cosine of B, which is square root of 2 over 2, minus cosine of A, which equals 1/2. So square root of 2 over 2, those can cancel out. I can multiply all the terms by 2, which gives me that tension A equals W over square root of 3 minus 1. Sorry, this is 2W over the square root of 3 minus 1. If I enter that into the calculator, that would give me that tension A equals 2.73 W and now I can take my tension A that I found and plug it into my tension B equation along with their angles. If I put that into the calculator, that gives me that tension B equals 3.35 W. So tension A in this system is 2.73 W, tension B is 3.35 W, while tension C equals W.